Okay, so quantum communications, for someone that has no knowledge about quantum physics or quantum mechanics, is like a way to do communications in a secure way. So the main advantage of doing this exotic communication is like you can produce some communication that is completely secure against any attackers. So for a deeper understanding of quantum physics quantum communications are exactly like the way to reduce the amount of photons that you send from one point to another in order to achieve the quantum advantages or the quantum phenomena that you can extract some value from that. So the thing is that instead of sending like 1 to the 8th power of photons, we send just one single photon. Doing that, reducing the amount of photons, we reach the quantum limit. So we somehow begin to study the phenomena with the quantum mechanics. And this quantum mechanics has a very interesting properties that we can use to protect the information that is sending from one place to another. And this property, the main property that we are using is the non-clone theorem. That is the fact that if we measure a photon, we somehow interact with the photon, and the sender will realize that the receiver has received a thing that is already touched. So it's a way to protect the thing that we are sending from an attacker in the middle, in a channel. So the main applications for this quantum communication is, as I said, for the little kids, is like securing the communication from one side to another. And also it's an effective way to produce symmetric keys. That if you have a very vague notion of cryptography, it's like to have the same key in one place and in the other, and you don't have to negotiate, you just produce and distribute the key in the same way. So for explaining that to a telecommunication engineering, for instance, that has no notion about quantum mechanics but has a lot of notion about how the communication works, at the end it's like to reduce the signal in such a way that we can use the properties of quantum mechanics to secure the communication. The thing that happens with classical cryptography, or the way that you do the communication and the cipher communication at the end in classical way, is to somehow negotiate with a public key and a private key in order to have a common key that is private and you can encrypt the message in a way that nobody in the middle can read it. But the thing is that this public and private communication can be broken with this quantum computer that will appear, and with a specific algorithm that is called SOR algorithm. So the thing is that factorizing the numbers is now easier for quantum computers, and then this way of negotiating the keys that we will use to secure our communication is not safe anymore. So the quantum communications in general and quantum key distribution in particular use the same properties that the quantum computer has to produce a secure key to encrypt the information, avoiding the threat of quantum computers. So there are two ways, like the quantum communications are doing that, but there are also another way to do that, that protect the cipher text or the cipher message from the threat of SOR algorithm. So to be SOR algorithm, there is another way that is a classical way that doesn't use the properties of quantum mechanics, that is the post-quantum algorithms. That in this project and also in many topics in the world, we have to mix all these two methods because this is a classical method that is resistant to this Solr algorithm that can break all the public cryptography in the world. So this post-quantum concept is just a classical algorithm that has a very, very difficult mathematical problem that is not factorizing, but is even complicated for quantum computing, at least with the algorithms that we know today. So there are these two ways, but the quantum communications are even greater, because with another property that the quantum mechanics has, that is the entanglement, we can also do teleportation, and there are many other protocols that could have that could break and somehow upgrade the communication that we know today to a better place.